Hey there, it's Alana, and we're back for some Excel videos, this time for Chapter 12. So I've already labeled my tab 12.1 number 15, and I'm going to save it as Tucky Chapter 12 Excel because I like the teacher to know my last name as well as what chapter I'm submitting. Hint, hint, hint. Now, let's see here. Let me go grab the book so you can see what we're going to be doing for this problem. Okay, here it is. We're going to be looking at number 15. So it says the National Traffic Safety Administration publishes reports about motorcycle fatalities and helmet use. The distribution shows the proportions of fatalities by location of injury for motorcycle accidents. So here are all the different distributions, and notice those are proportions. And the data below show the location of injury and fatalities for 2,068 riders not wearing a helmet. There we go. So does this distribution of fatal injuries for riders not wearing a helmet follow the distribution for all riders using the alpha equals 0.05 level of significance? In other words, here's the fit. How good does this fit that data, right? So let's see here. We're going to need to make an Excel spreadsheet, and we're going to have to write it all down. So let's start with our locations. Location. Ooh, and don't hit the cap locks key. Injury. We're going to need the observed, what we actually saw in real life, and we're going to need our expected. Okay. Just heading up, you know you're going to need to type in this table, right? Okay, so then let's see here. We saw the observed multiple head, neck, thorax, abdomen, lumbar spine. Okay. Now, what do we observe in real life? What really happened? Well, that's actually the second table here. We observed 1,036 here. We observed 864 here, 38, 83, 47. Now, what did we expect to have happen? Well, according to the distribution, it should be 0.57 times, well, we're looking at 2,068, right? So it'll be 2,068. And then it'll be equal to 0.31 times 2,068. Then it'll be equal to 0.03 times 2,068. And it'll be equal to why 2068? Well, because that's the number of riders we were looking at. So that's what you go with. So if you had been looking at 3,000 riders, you'd say times 3,000, whichever. Okay, so there's our observed, there's our expected. We're going to use these in a little bit. But first thing we're going to have to do is we're going to have to list out our null and alternative. So step one. The null hypothesis is that the proportions are here. The distribution of localities or injury localities follows the given distribution. That's one way you can say it. I mean, another way you can say it is that, I can say it out. The proportion for multiple was equal to 0.57. The proportion for head was, I don't remember what it was for head, is equal to, oh goodness, back here. Head is equal to 0.31, and so on, right? Oopsie, not there. That's totally not the right place. Cool. ... And then the alternative to that is that the distribution of injury locations does not follow the given distribution, which would mean at least one of the percentages is significantly different. At least one of the proportions of injury location is different. Cool. All right, I'll see you back here for the next step.